Hello. Welcome back to the second episode. They will be short episodes. So now we'll start with exploring the file storage. In the previous episode, lastly, we mentioned that there are two types of uh, of storing data. We have either file stores or databases. Now we'll work on exploring file storage. Now, the ability to store data in files is a core element of any computing system. Files can be stored in local file systems on the hard disk of your personal computer and on removable media such as USB drives, but in most organizations, important data files are stored centrally in some kind of shared file storage system. Increasingly, that central storage location is hosted in the cloud, enabling cost-effective, secure, and reliable storage for large volumes of data. Now, storing files is one of the most important concepts in companies or in firms or anything. Now, we can it's either in local file systems or on removable media or on the cloud. Now, sometimes big firms and companies use centralized shared file storage systems. What does that mean? It means that multiple devices are accessing the same hard disk or the same device that's storing the data to read and write from that piece of hardware. Instead of having 10 different hard drives with 10 different versions of the same file, no, there is only one centralized file, one centralized hard disk, which has one consistent version across all the systems. The specific file format used to store data depends on a number of factors, including the type of data being stored. We mentioned the types, three types: structured, unstructured, and semi-structured. The applications and services that will need to read, write, and process the data. Now we need to read, write, and process the data. The need for the data files to be readable by humans or optimized for efficient storage and processing. And now we'll need to look for optimization and readability. That data, we need to make sure that data is readable and optimized for efficient storage. Now, data don't consume more storage than needed. Now, there is one of the file formats. One of them is delimited text files. It's basically comma separated values. We store the data in comma separated values, which is in file formats called CSV. And rows are terminated by a carriage return or a new line. There are other types of storing the text files. TSVs, which is tab separated values, and space delimited, in which tabs or spaces are used to separate fields. And fixed width data, in which each field is allocated a fixed number of characters. Delimited text is a good choice for structured data that needs to be accessed by a wide range of application services in a human readable format. Sometimes when I'm saving data in a structured way in a database, that's fine. I'll save it somewhere. I'll save it somewhere. But when I want to share it, or I want to use it for humans to read it, I'll use CSVs. Usually, I'll use delimited text files to represent it because this is the following example. It's kind of readable. We can see here first name, last name, and email. Joe is the first name of this. For example, let's say this is a people table. It has three columns: first name, last name, and email. For the first person, Joe is the first name, Jones the last name, and this email is the last email, is the email for that person. Now, other kinds of storing data is JSON, JavaScript Object Notation. JSON is a ubiquitous format in which a hierarchical document schema is used to define data entities, objects, that have multiple attributes. Each attribute might be an object or a collection of objects, making JSON a flexible format that's good for both structured and semi-structured data. Previously, we mentioned that unstructured data is usually you can be represented using JSON. That's not only for semi-structured, it's also possible to represent structured data in a JSON format. Both semi-structured and structured data can be represented using JSON files. The following example shows a JSON document containing a collection of now the JSON is basically an object that contains objects. Entities that are it's objects that might contain objects in serial of objects. I'll explain it in a second what is meant by an object. The following example shows a JSON document containing a collection of customers. Each customer has three attributes: first name, last name, and contact. And the contact attribute contains a collection of objects that represent one or more contact methods. Note that objects are enclosed in braces and collections are enclosed in square brackets. Attributes are represented by name value pairs and separated by commas. Now, JSON is basically defined data entities which are objects that have multiple attributes. Each attribute might be an object or a collection of objects. Okay, let's look at it. This is the JSON file. It starts with brace and then ends with a brace. Okay, curly brace. It starts with an entity. The entity is called customers. This customers has multiple attributes. It can be multiple customers. For example, here we have two customers. Now we know that the first customer starts here and ends here. It's separated by a comma, and the second customer starts here and ends here. Now, customers might be contained in square brackets. Because I have two customers, multiple customers, it's represented as if it's in an array. That's how an array is represented in JavaScript. Then curly braces, which ends here. Now, let's look at the content. It's an attribute. The first attribute is called first name, which is Joe, separated by a comma. Last name, Jones, separated by a comma. Contact. Now, this is an attribute, an object that contains multiple objects. An attribute that contains an attribute that contains multiple objects. These objects, for example, here we have two objects. It's look here. It starts with a square bracket, but and ends with a square bracket and has multiple information because it contains multiple attributes. Maybe home, maybe emails. We can have multiple attributes here, and it's separated by curly braces here, comma, curly braces here, which has multiple attributes. This is separated from this. This represents something, and this represents something else, which is separated by braces. Now let's look at the second customer. The second customer is multiple attributes: first name, last name, contact. Contact has one attribute, has one object inside it. Even though we started with the square brackets, it doesn't really matter because it's not separated with a comma. It just represents that it's a sort of an array, which means that it can hold multiple contact information, but here we have only one, which is not separated by any commas. Now there is another kind which is called XML, Extensible Markup Language. If we look at it, it looks like like an HTML. It looks like HTML, but it's an old way of representing data. XML is a human readable data format that was popular in the 1990s and the 2000s. It's largely been suspended by the less versatile JSON format. JSON format is mostly just took over this XML format. But there are still some systems that use XML to represent data. XML uses tags enclosed in angle brackets to define elements and attributes as shown in this example. Here we have multiple customers. It starts here and ends here. Customer name Joe, last name Jones. Contact details because we have multiple information, so we just start it here and end it here. Contact details. The This is the first customer. This is the information of the customer, and this is the end of the first customer. This is the start of the second customer, and this is the end of the second customer. It starts and ends with the customer's tag because it has multiple customers inside it. Blobs. What are blobs? Binary large objects. Ultimately, all files are stored as binary data, ones and zeros. But in the human readable formats discussed above, the bytes of some binary data are mapped to printable characters, typically through a character encoding scheme such as ASCII or Unicode. So basically, all data is stored in ones and zeros, but some of them are stored in a way, but to be represented, they are stored in as ones and zeros, but when they're represented through a readable format, which is usually the ASCII or the Unicode. Some file formats, however, particularly for unstructured data, store the data as raw binary that must be interpreted by applications and rendered. Common types of data stored as binary includes images or video, audio, and application-specific documents. Now, for example, we're not dealing with words. We're not dealing with words. We're not dealing with something that is represented by ASCII or Unicode. We need to. It's usually immediately translated into an audio or a video or a picture or an application-specific document. When working with data like this, data professionals often refer to the data files as blobs, binary large objects. That's the blob ideas. Now, let's go on with the optimized file formats. While human readable formats for structured, semi-structured data can be useful, they're typically not optimized for storage space or processing. Over time, some specialized file formats that enable compression, indexing, and efficient storage and processing have been developed. Some common optimized file format you might see include Avro, ORC, or Parquet. Now here we're trying to for example, now we have files that represent that has representable data which humans can see and use, can and understand, not particularly used. Some of them are not unusable directly. So we need to optimize and compress them. We need to optimize and process them. Some of the ways are Avro or Parquet. Let's read more about them. Avro is a row-based format. It was created by Apache. Each record contains a header that describes the structure of the data in the record. This header is stored as JSON. The data is stored as binary information. An application uses the information in the header to parse the binary data and extract the fields it contains. Avro is a good format for compressing data and minimizing storage and network bandwidth requirements. Now, it's basically first point. It's row based. Each row is uh, each row is processed on its own, and it was created by Apache. Each record contains, if each record, as in each row, contains a header that describes the structure of the data in the record. It's basically, we need to imagine that a row is recorded in a specific way. So we record it's processed and optimized to be usable in a certain way. Each row, we'll call it a record, and the record is mainly separated into two parts: the header and the data. The header contains information about how the data is stored and its structure. Okay, and this header is stored as a JSON. The header is stored as a JSON, but the data is stored as binary information. An application uses the information in the header to parse the binary data and extracts the field it contains. Now, there is an application where we'll use the where we'll put the Avro file, where we'll put the Avro file in which it understands, in which it processes, it reads the JSON, the header part, understand the structure of the data of the file, and reads it and represents it. And it extracts the field it contains. Avro is a good format for compressing data and minimizing storage and network bandwidth requirements. Now, the second one, ORC, Optimized Row Columnar Format, organizes data into columns rather than rows. It was developed by Hortonworks for optimizing read and write operations in Apache Hive. Now, data in ORC, Optimized Row Columnar Format, it's separated into columns rather than rows. It was developed by Hortonworks, okay, in Apache Hive. Hive is a data warehouse system that supports fast data summarization and querying over large datasets. When we have large amounts of data, we're likely using Apache Hive, which uses ORC to store its data. An ORC file contains strips of data. Each strip holds the data for a column or a set of columns. A strip contains an index into the rows in the stripe, the data for each row, and the footer that holds statistical information. Count, sum, max, min, and so on for each column. Now, the ORC file will contain the data, the strips of data. What does a strip of data? What is the strip of data? It's either a column or multiple columns. Now, there is a stripe that contains an index into the rows on the stripe, the data for each row. Now, when we're dealing with multiple columns, we'll have when we have in each stripe multiple columns, then each column will have multiple rows. Each stripe will have multiple rows. Now, for these rows, we'll need some sort of checker, something that checks the data and the data that we're having. A stripe contains an index into the rows. Now we'll know the index of each row, the data for each row, and the data in the row and the columns, and the footer that holds statistical information, count, sum, max, min, and so on for each column. Now, some in the footer will hold some sort of checker. So, an ORC is made of strips. Each stripe can be a column or multiple columns. Now, in the stripe, we'll have three things: the index of rows, and the data each stripe will contain the index for each row, the data for each row, and the footer that holds statistical information to make sure that the information we're having is correct overall. Parquet. Parquet is another columnar data format. It was created by Cloudera and X. A Parquet file contains row groups. Data for each column is stored together in the same row group. Each row group contains one or more chunks of data. So, a Parquet file contains row groups. So we'll have groups of rows. It's another columnar data format. So it basically organizes data into columns instead of rows, but the Parquet file contains groups of rows. Okay, data for each column is stored together in the same row group. So basically, the Parquet file is how is it represented? It's represented in row groups. Each row group is stored together. Each data for the same column is stored in the same row group. Data for each column is stored together in the same row group. So, okay. We open a Parquet file. What we're supposed to see? We're supposed to see rows. What does a row represent? A row represents data for each column. The first column would be, for example, in the first row. And they're all the same column is in the same row group. Each row group contains one or more chunks of data. We might have multiple chunks of data in each row group. A Parquet file contains metadata that describes the set of rows found in each chunk. Now, we need something to describe the data that we're having, because some data might be encrypted or formatted in a certain way that's not readable for humans, but an application needs to read that certain file. And when an application needs to read a certain file, it needs to have some sort of key to read the content of each file. So in Parquet, we use the metadata that describes the sets of rows found in each chunk. An application can use this metadata to quickly locate the correct chunk for a given set of rows and retrieve the data in the specified columns for these rows. Now, I need a certain row in a huge collection of data. What happens is that an application would access these Parquet files. They would find, using the metadata, they would find the correct, using metadata, they would find the correct chunk of data where now when we open a Parquet file, sorry about that, when we open a Parquet file, I need specific sets of rows. Now, each row would be uh, each row. Now I need to locate a certain chunk of data, a certain row. Using the application would use the metadata to find the row that I'm looking for and extract the data from it. Parquet specializes in storing and processing nested data types efficiently. It supports very efficient compression and encoding schemes. All right, this was a long unit. I shouldn't have taken this long in it. I'm overcomplicating stuff and over-explaining several aspects. I will note my issues and try to work on them. Thanks for watching.